Namaskar, Adab, Shat Sri Akal. Welcome to our channel, and I would like to say I'm going to continue this group theory course, and tonight we are going to discuss some results related to cyclic subgroups. So certainly in the previous lecture we have discussed what are cyclic group, how we are going to generate a particular cyclic group, okay, with respect to addition, with respect to multiplication. Everything were discussed in a very beautiful manner. I would like to say this evening is dedicated for some discussion, okay. And I would like to say this evening we have not come up with the PDF of questions, I mean to say MCQ and 4.75 type, but yes, we have come up with some results. We'll discuss everything in detail, that why a particular group is cyclic and why a particular group is not cyclic. If cyclic, then how many generators will be there? If not cyclic, if cyclic, then how many generators will be there? And if not cyclic, then what is the actual reason behind that? Okay, so yes, we are going to discuss each and everything in detail. Before this, we already know that if we have a cyclic group, so cyclic group is abelian, but an abelian group may or may not be cyclic. It depends whether we are able to find a generator or not. I would also like to say that on this channel we have already completed a real analysis, and certainly you may check the playlist and for the solution of previous year questions. Okay, so now let's go to start this session in a proper way. And I would also like to say that certainly today's class will be a bit slow, but the discussion will be very nice. So I'm going to start this session with a question that if you are given Z, L and F, then when it is going to be a cyclic or not. Okay, because Z, L and F is what? Certainly a group of non-singular matrices, we all know already. Okay, and we will also discuss what about SLNF, a special linear group of matrices of order n by n whose entries are from F. What is going to happen if we have different kinds of fields? Okay, so all these things are going to be discussed in a very beautiful manner. But first of all, I would just like to ask you, what do you say about this SLNF? Is it cyclic? Okay, and later we will discuss about ZLNF also. So yes, my first question is this SLNF cyclic? What would you like to say? First of all, I am going to discuss about SLNF, and thereafter we will certainly discuss about ZLNF as well. So what do you think? If SLNF is cyclic, then for which n it is going to be cyclic, and for which n it is not cyclic? This is also a question. SLNF is what? A group of n by n order matrices whose entries certainly belongs to F and determinant is 1. Okay, for example, if A represents a matrix, then the determinant of this matrix is 1, and this Aij belongs to where? Certainly from F. Then what would you like to say about this SLNF? I would like to say for n is equals to 1, it is going to be cyclic, because for SL1F we are going to get what? A singleton 1, and a singleton 1 is what? Obviously okay, only one element is there, and it's a obvious cyclic group. But what happens if your n is greater than or equal to 2? So if your n is greater than or equal to 2, then in that case SLNF is what? Certainly non-abelian, and as it is non-abelian, therefore certainly it will be non-cyclic, because a cyclic group is abelian. So what about its contrapositive statement? है ना, cyclic group abelian होता है, तो उसका contrapositive statement क्या होगा? If not abelian, then not cyclic. So yes, the conclusion is here for SLNF, a special linear group of order n by n matrices over the field F. What is the conclusion? The conclusion is that it is non-abelian for n greater than or equal to 2 and it is abelian for n is equals to 1. Now the next question is, what about Q with respect to addition? Q, I mean to say the field of rationals with respect to addition, will it be a cyclic group? What do you think? The answer is no. No, it is not going to be a cyclic group. Why? Because we know if Q is cyclic, then certainly it must have some generator. Okay. And what the thing is going to happen, because we are talking the things with respect to addition. Okay, so with respect to addition, there must be an element in Q and all the other elements should be written as the integral multiple of that. But what happens? Actually the answer is no. And why? Because we are not able to find any generator in Q. How can you justify it? Certainly we can take, let Q is cyclic if possible. Okay, if possible, then suppose Q is cyclic if possible. Okay, let Q be cyclic if possible, and if it is cyclic, because we have taken this as cyclic, therefore certainly there must exist an element Q such that this Q is going to be generated by A. And what do you mean by this Q is going to be generated by A? It means this Q, every element of this Q can be written as an integral multiple of A. So n into A such that n belongs to Z. But certainly we will get a contradiction, because yes, we are going to prove that Q with respect to addition is not cyclic with respect to addition. But as we have supposed that Q is cyclic and generated by A, so certainly we must have some contradiction, and by using the method of contradiction we will be able to say that as we have gotten contradiction, so our assumptions were wrong. Okay, so yes, in this way we are going to prove it. So if possible, let A belongs to Q. Just a second, let A belongs to Q, then what the thing is going to happen? Then certainly either our A will belongs to Z, I mean to say your A will be either integer or A will be non-integer rational also. Okay, because if we are going to take a rational number A from Q, then either this A belongs to integer or A does not belongs to integer. Now what happens if A belongs to Z? If A belongs to Z, then what do you think about the generators? Certainly if A belongs to Z, then possible value, I mean to say the possible generators will be what? Possible values of A is what? Either 1 or -1, है ना? अगर A Z के अंदर से बिलोंग करता है, क्योंकि Z Q के अंदर है, तो यहाँ पे क्या कह सकते हैं कि A या तो इंटीजर होगा या नॉन इंटीजर होगा. If A is integer, then the possible values of A is what? Either 1 or -1. If A is equals to 1, if A is equals to 1 and A is equals to -1, A is equals to -1, या तो A 1 है या फिर -1 है, then 1/2 is not generator. ठीक है, 1/2 is not generated. ओके, बिकॉज 1/2 जो है वो हम नॉन इंटीग्रल रेशनल नंबर है. ठीक है, अब नॉन इंटीग्रल रेशनल नंबर है तो हमें यहाँ पे 1 से जनरेट करना है, तो यहाँ पे हमें क्या चाहिए? लिस्ट पॉजिटिव इंटीजर चाहिए. सो वी डोंट हैव एनी लिस्ट पॉजिटिव इंटीजर विच इज गोइंग टू मल्टीप्लाइड बाय 1 and we are going to get 1. So it is not possible. So from here it is clear that A certainly does not belongs to Z. Okay, and in that case A belongs to Q without Z, then what the thing is going to happen. तो यहाँ पे हमने देख लिया कि 1 या -1 जो कि जनरेटर होता था Z का, वो Q का जनरेटर नहीं हो पाया. तो अब हमारे पास जो दूसरा रास्ता है वो ये है कि वी कैन टेक दिस A belongs to Q without Z. I mean to say we are going to take this A as non-integral rationals. Then what the thing is going to happen? If A belongs to non-integral rational, then 1 over A plus 1 or 1 over A plus 2 or 1 over A plus 3 and so on is not generated by 1 by A, is not generated by 1 by A. Okay, therefore what the conclusion is there? So A does not belongs to Q without Z. So once again we have gotten fact that A does not belongs to Q without Z. So once again we are going to get a contradiction because we had taken this and the conclusion is this: A does not belongs to Q without Z. Okay, so we can say that here we don't have any A in Q such that A is going to generate this Q. ओके, हमारे पास कोई भी ऐसा A Q के अंदर नहीं है जनरेटर के रूप में जो कि Q को जनरेट कर सके. ओके, सो एज वी डोंट हैव एनी जनरेटर देयरफॉर वी शैल से व्हाट Q इज नॉट साइक्लिक. ठीक है, तो यहाँ से ये क्लियर हो गया कि Q विथ रिस्पेक्ट टू एडिशन जो है वह साइक्लिक नहीं होगा. इट इज क्वाइट क्लियर. Once again, somebody can ask you whether this R with respect to addition or they may ask C with respect to addition. Are these groups cyclic? Then the answer is obviously no. Why? Because both of these two groups is going to contain this Q with respect to addition. So certainly we can say Q is the subset of R, Q is the subset of C as well. Okay, but Q with respect to addition is not cyclic, therefore these R with respect to addition and Q with respect to addition is also not cyclic, because the subgroups should be cyclic also if you have a cyclic group, but here we are going to get a non-cyclic subgroup of R and C, therefore we shall say what? It is not cyclic at all. Okay. In the same way, if we are going to ask about Q star, I mean to say non-zero rationals with multiplication, okay, R star non-zero reals with respect to multiplication, C star with respect to multiplication, non-zero complex with respect to multiplication. So certainly these are also not cyclic because we are not able to find any generator. Okay, so that's why this is not cyclic. Now that interesting question is over here, that if we have a general linear group of n by n order matrices with on field F, will it be a cyclic group? Then what would you like to say? Once again you will see and say that this is not going to be a cyclic group even for n is equals to 1 also, because if you will have n is equals to 1 and if we are going to take our F as set of reals or complex or rationals, then what the thing is going to happen? ZL1F, what the thing is going to happen? So actually we will get the elements matrices of order 1 by 1 with determinant non-zero. Therefore we can say what? These are just the singletons from either from R or from Q or from C. So we can say what? If we will take the field as R, then this GL1F is nothing but R star with respect to multiplication. If we are going to take the field as Q, then this GL1F is nothing but the non-zero rationals with respect to multiplication. If we are going to take the field as C, then this GL1F is nothing but this C star with respect to multiplication. and in all these three cases, what the thing we are going to get, we know all these three are what? Certainly non-cyclic. We had already seen. So even for n is equals to 1, this GL1F is what? Non-cyclic. n बराबर 1 के लिए भी GLNF क्या होगा? Non-cyclic होगा. ठीक है. और n ग्रेटर देन और इक्वल टू 2 के लिए तो GLNF नॉन अबेलियन होता ही है. इफ वी हैव GLNF for n greater than or equal to 2, then certainly this is what? Non-abelian, and non-abelian implies what? Non-cyclic, है ना. Non-abelian हो जाएगा, और non-abelian किस चीज़ को इम्प्लाई करता है कि ये non-cyclic होगा. ठीक है. तो SL1F स्पेशल लीनियर क्या हो गया था? n बराबर 1 के लिए साइक्लिक हो गया था, क्योंकि सिर्फ आइडेंटिटी 1 आता. लेकिन GLNF जो है n इज इक्वल टू 1 के लिए भी साइक्लिक नहीं हुआ. तो फॉर किसी भी n के लिए GLNF साइक्लिक नहीं है. लेकिन जो स्पेशल लीनियर ग्रुप है वो 1 के लिए SL1F वो साइक्लिक हो जाएगा, लेकिन 2 और 2 से अधिक ऑर्डर के लिए वो फिर साइक्लिक नहीं होगा. ठीक है. यस. लेकिन एक चीज़ यहाँ पर बहुत इंपॉर्टेंट है. यहाँ पर देखिए, हमने जो फील्ड लिया, ये R लिया, C लिया, Q लिया, इनफाइनाइट फील्ड्स लिए. लेकिन इफ वी आर गोइंग टू गेट F इज इक्वल टू सम फाइनाइट फील्ड, देन GL1F विल बी साइक्लिक. यस, दिस इज अ नोट. सो यू मस्ट नोट दैट GLNF, if your F is either R or C or Q, then this is not cyclic at all for any n. But if we are going to take the fields like in the case 2, if we are going to take the field F like FQ, or sometimes we used to say ZQ, then for n is equals to 1, it will be what? GL1FQ. Remember, this FQ is a finite field, so certainly this will be of FQ star. Okay, and this FQ star will be isomorphic to UQ, and this Q is prime, then it will be isomorphic to ZQ minus 1. Okay, and Zn is what? Always cyclic. So we can say what? This GL1FQ, if this is a finite field, then certainly Zn is a cyclic group. So for n is equals to 1, if your field is finite, then it will be cyclic. But for n greater than or equal to 2, even for n greater than or equal to 2, no matter your FQ is finite, भले ही आपका FQ finite भी हो जाए, लेकिन n greater than or equal to 2 होगा. So in this case it is going to be non-abelian, and non-abelian implies what? Non-cyclic for sure. So you must have to note all these, है ना. कब cyclic होगा, कब cyclic नहीं होगा, you must have to note it. So what the note is? For GLNF, your F is real or complex or rational, then this is not going to be cyclic for any n. But in this case, if your n is equals to 1 and your field is finite, then in this case for n is equals to 1, GL1FQ is going to be a cyclic group because it is going to be isomorphic to Zn. But if your n is greater than or equal to 2, then your GLNFQ, no matter your FQ is a finite field, however it is non-abelian, because multiplication of matrices are non-abelian, and therefore nobody will stop you to say that this is non-cyclic. Okay, so yes. Now once again I would like to ask, what would you like to say? Is UN cyclic? What do you think? Is UN group cyclic? Then what will be your answer? This is a very simple question right here. So certainly your answer will be what? Answer will be need not be. Need not be. Okay, certainly we have some results, we have some specialization. If your n will be of a particular form, then it will be cyclic. But in general, if you have UN, then certainly your answer will be it need not be a cyclic group. For example, if I am going to ask you about U15, then you can certainly see this U15 can be written as how? This is the product of two primes as 3 and 5, and certainly this will be isomorphic to what? Z2 cross Z4. isn't it? How? Because यहाँ पे u3 इंटू u5 हो जाएगा और u3 है, ठीक है, तो वो आइसोमॉर्फिक हो जाएगा z2 के, u5 है तो आइसोमॉर्फिक हो जाएगा z ऑफ 5 के, 5 इज 4, therefore it will be isomorphic to z2 cross z4. But this z2 cross z4 is not a cyclic group. Why? Because z2 cross z4 में जो एलिमेंट्स का ऑर्डर है वो LCM ऑफ 2 and 4 यानी 4 ऑर्डर से ज़्यादा का कोई भी एलिमेंट z2 cross z4 में नहीं होगा. We don't have any elements of order 4 in z2 cross z4, but the order of z2 cross z4 is 8. What does it means? It means this group z2 cross z4 does not have any element whose order is equal to the order of this group. It means z2 cross z4 does not have any generator and therefore it is non-cyclic. Okay, but on the other way, I can also say one thing, that if somebody will ask you about u25, okay, then this u25 is certainly isomorphic to z of phi of 5a square, okay, and this phi of 5a square is what? Certainly isomorphic to what? What would you like to say? Phi of 5a square, so it will become z 5 ka square minus 5, okay, so it will be isomorphic to z20 and this is certainly a cyclic group. So that's why u25 is cyclic undoubtedly. So if anybody will ask you about un, then you can say sometimes it is cyclic, sometimes it is not, but what is the result? So that you can say un is always cyclic. So I would like to say that you must remember this beautiful result, that if you have u p raised to the power n, where p is odd prime, where p is what? Odd prime, then upn is always cyclic. Then upn is always cyclic. Certainly we will have some justifications for this. Undoubtedly we will have some justifications for this. Why? Because if you have u p raised to the power n is isomorphic to z phi of p raised to the power n, and it will be isomorphic to what? Certainly z p raised to the power n minus p raised to the power n minus 1. Okay, so your p should be odd prime for sure. If your p is not equals to 2, if p is odd prime, okay, then in that case we will not hesitate to say that this z p raised to the power n minus p raised to the power n minus 1, this is a cyclic group. So we will not have any hesitation to say certainly this is cyclic. This u of p raised to the power n is cyclic. So now we are interested in some product of groups, and it will be very interesting to see. Somebody can ask you, if you are given G is equals to S3 cross Z2, then will it be a cyclic group? They may ask, but by just seeing it, you will say, oh, this S3 is non-abelian. This S3 is non-abelian. So overall this S3 cross Z2 is non-abelian, and non-abelian implies non-cyclic. Okay, so without any justification, just by saying the things, you can say this S3 cross Z2 is non-cyclic. Okay, now I am going to ask another thing. If you are given Z is equals to Z5 cross D1, is it cyclic? Then you can easily see that yes, it is cyclic, because Z5 is cyclic, D1 is cyclic, and its product will be cyclic as well. Then somebody will ask what will be the generator. So we will take 1 from Z5 and F0 from D1, and then this G is going to be generated with the help of this element, and we will not hesitate to say that this is going to be a cyclic group. And certainly the order of Z is what? What is the order of Z? 5 elements from here, 2 elements from here. So the order of Z is 10 and the order of 1 comma F naught is also 10. So certainly this is going to be a cyclic group. Okay. And one thing is very interesting, you must have to note it, a very interesting note. If G1 and G2 are cyclic group, if G1 and G2 are cyclic group, then its product is not necessarily cyclic. Yes, if G1 and G2 are cyclic group, then G1 cross G2 need not be cyclic. Yes, it's true, need not be cyclic. I would like to say, before this we had already seen that yes, both were cyclic, its product is cyclic because it has the element of order 10 as well. But one very interesting note is what? If you are given G1 is cyclic, G2 is cyclic, then their product may or may not be cyclic. Yes, it's a fact. Because if you have a group G1 as Z4, okay, and if you have a group G2 as Z6, then certainly this is a cyclic group. You all know this Z6 is also a cyclic group. But what about its product? What do you think about Z1 cross G2? Certainly this is Z4 cross Z6, isn't it? And order of Z4 cross Z6 is what? You will not hesitate to say it's 24. Okay, it's what? 24. But when you will try to find the order, then you will find what? But this Z4 cross Z6 does not have any element of order greater than 2. Okay, but this Z4 cross Z6 does not have any element of order ग्रेटर देन 2. ठीक है, लेकिन इसके पास 2 से ज्यादा ऑर्डर का कोई, मतलब Z4 क्रॉस Z6 के पास 2 से ज्यादा ऑर्डर का कोई एलिमेंट ही नहीं होगा. कैसे? एलसीएम ऑफ 4 एंड 6 देखा जाता है, जबकि ग्रुप का ऑर्डर 24 है. ठीक है, तो अब क्योंकि 24 ऑर्डर का एलिमेंट Z4 क्रॉस Z6 में है ही नहीं, इसका मतलब क्या हुआ? Z4 क्रॉस Z6 डज नॉट हैव any generator. So as Z4 cross Z6 does not have any generator, it means this Z4 cross Z6 is not cyclic. Okay, so here it was a very interesting note that even if you have two cyclic groups, but their product may or may not be cyclic, and this is really very interesting example. You must have to note it. Here G1 was cyclic, G2 was cyclic, but G1 cross G2 may or may not be cyclic. Example is here in a very beautiful manner. Now once again I am just going to ask if anybody is there, then certainly they can say yes or no. And in this time I can see Jalajji is there. Jalajji, you are welcome. You are welcome over here. I am just going to ask a very simple question. As G is equals to Z cross Z, will it be a cyclic group? What do you think? Z cross Z, will it be a cyclic group? What do you think? The product of Z and Z, will it be a cyclic group? Yes or no? So what would you like to say about it? Will it be a cyclic group? The answer is no, है ना. Z क्रॉस Z जो है ये आपका साइक्लिक ग्रुप नहीं होगा. कारण क्या है कि Z क्रॉस Z, है ना, दो साइक्लिक ग्रुप है तो भी उसका प्रोडक्ट कोई ज़रूरी नहीं है कि साइक्लिक हो. एग्जाम्पल हमने देखा था और भी यहाँ पे देखेंगे. A belongs to Z, B belongs to Z. Yes Jalaji, you are right. So if possible let X, Y belongs to Z cross Z. अगर संभव है तो X, Y Z cross Z में ले लेंगे इस तरीके से, such that this Z cross Z is going to be generated by X, Y. Okay, this is going to be generated by X, Y. Then what the thing is going to happen? Either there will be one case in which X is equals to Y. If X is equals to Y, then what the thing is going to happen, 1 comma 2 belongs to z cross z cannot be generated for sure, है ना. If your x is equals to y, then 1 comma 2 belongs to z cross z, such that this 1 comma 2 is not generated by x comma x. आप नहीं लिख सकते हैं 1 comma 2 को, because if we have 1 comma 2 and let's say if you have x comma x, then if you will put any list positive integer over here, then you are not going to get 1 comma 1, because at this place x and at this place x only. And if you are going to put any list positive integer over here, then you are not going to make this 1 comma 2. Therefore, we cannot take x comma x as the generator for this 1 comma 2, isn't it? And therefore, if your x is equals to y, then this is not going to be a generator. I would like to say simply that if these two elements are different, then a generator with same element at both the coordinate place, we are not going to generate this kind of elements with this kind of generators. And in the same manner, what would you like to say for the second case, that if x is not equals to y, okay, then 1 comma 1 belongs to z cross z, such that 1 comma 1 is not going to be generated by x comma y. 1 comma 1 is not generated by x comma y, because if we are taking x and y are two different things, and if we try to generate this 1 comma 1, then certainly we need to put some integers over here. But if you will put any integer over here, and if this x and y are two different things, then you will not be able to make this 1 comma 1. Okay, and that's why for these kind of elements, this x comma y is not able to generate this kind of elements. Okay, so certainly if we are going to take x and y different, then infinite number of elements like 1 comma 1, x comma x is not going to be generated by that. And if we are going to take 1 comma 1 as the generator, then the elements which are different, whose abscissa and ordinate are different, they cannot be generated by 1 comma 1 type element. Okay, so in this way I can say what? There does not exist any element in z cross z, so that all the elements of z cross z can be written as the integral multiple of that. So we can say what? This z cross z has no generator at all. No generator at all. And therefore, you will not hesitate to say this is non-cyclic. Okay? Yes. So this is non-cyclic. Once again, I would like to ask a few simple questions. If you will be given z cross z, then what would you like to say? Certainly it's not cyclic as well. This is also not cyclic. Okay, if somebody will ask you about G is equals to Q cross Q, then what would you like to say? Certainly this is non-cyclic as well. This is non-cyclic as well. Okay. So yes, these were a few simple questions, and I would like to tell you all that on our Telegram channel, I think I had taken a break of 2 or 3 days, but from tomorrow onwards, certainly I will send a set of questions on our Telegram channel. I will send a set of questions on my WhatsApp group. Okay, and certainly we will play in better way from tomorrow onwards. Certainly the questions will be of 4.75 type. Okay, and the continuous class will be there at 8:30 p.m. daily. Okay, so thank you very much everyone for watching, for coming, and certainly we will continue our lecture series for sure. Okay, so we'll see you in the next class. Till then, take care. Bye bye. Good night.